Hey guys, welcome to Shaker Tech YouTube channel. Today we are going to discuss about voltage source and current source. So we will be having voltage source and current source. Again, ideal voltage source and practical voltage source, ideal current source and practical current source. Now let us discuss one by one. This is very important in examination point of view also. So first let us see ideal voltage source. So the voltage source that provides a constant voltage across circuit for any change in load current or load resistance. This is the definition of the ideal voltage source. So what it means is actually, so ideal voltage source nothing but which gives constant voltage. For example, this is the circuit diagram. This is the voltage source. So it states that the voltage remains constant across the load irrespective of any change in load current and load resistance. So it means whatever the voltage we are applying, that will come to load. So the across the load. So what is the across the load voltage? VL. So this is the output voltage, this is the input voltage. Simply ideal voltage source is saying that the input voltage is equal to output voltage across the load. That is the main definition of the voltage source. So for example, what is the voltage formula? V is equal to IR, right? So this VL nothing but the always constant. Voltage is always constant if you change any load current or load resistance. So this change is does not affect on the voltage, that is called ideal. For example, VL is equal to IL into RL, right? So if we change in any IL, so IL equal to 2 amperes, let us assume, and RL equal to 3. 2 into 3, 6 volts. Again, if you change in 3 into 3, so 9 volts. So if change in this IL and RL, it should change, but it will not change. So that is the ideal voltage source. So it means input voltage is equal to output voltage. This is the definition of the ideal voltage source. If you see the graph, so this is the VL and this is the IL and RL. So this is the, when you increasing this IL and RL, and it won't increase, this voltage also remains same. VL is equal to VS is equal to VL. So this is the definition. Simply remember that ideal nothing but input is equal to output. Input voltage source is equal to output voltage. So that is the basic definition of ideal voltage source. Next, you can see practical voltage source. What is meant by practical voltage source? Okay, so this is the practical voltage source. So now see the same circuit. So there won't be any definition. Just you, I will discuss it. So this is the same circuit diagram, but here there is a one thing extra. What is that? Internal resistance. This small r is called internal resistance. So this is a source voltage. We are giving same again IL and RL. So for this circuit, you apply this voltage and what will happen? What is about the VL? So here practical voltage source Vs is not equal to VL. Why? Now we have to see. Okay. So here to discuss about that, we have to apply Kirchhoff voltage law across the circuit. What is Kirchhoff voltage law? So voltage law says that the sum of algebraic voltage drop plus and voltage sources in the circuit is equal to 0. It means sum of voltage drop. What is the voltage drop? I into RL. This is one voltage drop. Same current passes like this. This IL into small r. This is another voltage drop. These drops plus voltage source. How many voltage sources are there? Only one voltage source is there. So this all is equal to 0 in a given circuit. That is the Kirchhoff voltage. Just to apply this here. So here minus ILRL. So when you are going from higher potential to lower potential, so we should take voltage drop here minus. I will tell you clear why it is minus in next class. Okay. So for time being, you please remember. And this is again IL is coming here. Again higher potential, lower potential. So when you are moving from higher potential to lower potential, you have to take minus sign. So minus ILRL and plus Vs. So this is lower potential to higher potential. So negative to positive. So this sign you should remember. Okay. So this is a plus. So this drops, voltage drops 1, 2. This is a voltage source. All is equal to 0. So this is the Kirchhoff voltage law. So next here when you rewrite these equations, the minus IL all nothing but we can write minus VL, and same this equation. So if you move this minus VL to right side, so we can write minus IL plus VS is equal to VL. So this is just you rewrite this VS minus VR is equal to VL. So this is the practical voltage source. It means here VS is not equal to VL because of this internal resistance, this drop. So when you see the graph, so this is the graph actually. So this is the ILRL and this is the VL. So this VS actually, and this is a drop across the small internal resistance. So due to this drop, VS is not equal to VL. VS is not equal to VL. So this is the practical voltage source. It means you should remember that any practical voltage source is input is not equal to output. This is the basic idea and basic concept you should remember. Simply you should remember that practical sources, the input is not equal to output. Input voltage source is not equal to output voltage. That you should remember. Okay. I hope you understand this. And so next we'll discuss about ideal current source. Okay. What is mean by ideal current source? Just move on. So next, ideal current source. What is ideal? So the simply definition, it gives the constant current in the circuit even if load is changed. So what it is saying? It's saying constant current. So constant current irrespective of the load.